Spherical coordinates. In the last section of Chapter 1, you're introduced to two new methods for graphing in 3 dimensions, cylindrical and spherical coordinates. And I think they could be difficult to picture if you haven't worked with these. We're so used to using the Cartesian coordinate system. There's lots of nice applets online, and the next link on the class page is one that gives you some practice at cylindrical coordinates. So I'd like to walk you through a couple of problems with that. So when you open up the web page, you should get, this will be the link, and if you click on here, you'll be connected to a little short interactive application. And so here we can see point P, and how do we define it spherically? By the angle phi, which is the angle off the positive z-axis. The angle theta along the xy plane off of the positive x-axis, and rho, the length of the ray connecting the origin to the point. And we could move things around. For example, if I want to change, if the point is somewhere else above the xy axis, if I change theta, notice that the angle is becoming greater. Now I'm going past pi over 2. I could change the angle off of the z-axis. That's going to be my parameter phi. It can decrease or increase. Let's see if we can get it down below the x-axis. There we go. And I could also change the length of the ray rho. But what I'm really interested in is looking at a couple of practice problems. So you could play around with that if you'd like, but here's some nice practice problems. So here's the first one. We've got what looks like a half of a sphere, of a hollow sphere, so sort of a shell. And right here we're shown what the coordinate system looks like. If I'd like to look at it from some different angles, I could move this around. That's kind of nice. I could see what it looks like from the bottom. It sure is half a sphere. Let me reset it, and here's the possible choices I might have. So here's my x-axis, my y-axis, and my z-axis going up. And it appears that the sphere is undefined for phi from 0 to pi over 2. But it picks up all of the points from pi over 2 to pi. So looking over here, phi, 0 to pi, no, I don't have that point there, 0 to pi. Pi over 2 to pi appears to be what I'm seeing here. So I'm thinking now that 3 is the correct answer, especially since the first one only goes from 0 to pi, which is none of those points are visible there or included in the graph. Let me look at something else. Rho appears to be a radius of 1, and that's true for all of these points on this shell, but it's also true for all of these choices here, so rho doesn't really help me out here. I think that 3 is a choice. Let me just check my theta. Theta goes from 0 to 2 pi. In other words, we go completely around. We're not looking at just half or a quarter of this shell. So I believe that this is the correct choice, and in fact, yes, it is. Let's take a look at another one here. This should be, oops, let's look at this one. This looks like a nice, easy one. So think about this for just 1 minute. Here's our choices. If you'd like to, when you look at it, we can move it, but I'm just going to reset it. So which of these do you think is the correct answer? Well, if you said A, you're correct. Phi only takes values at pi over 2. So if I come down pi over 2, I have points along this circle here. It also takes values from 0 to 1 as far as the distance from the origin, and it's around the x-axis. Theta is equal to 2 pi, so we have a complete circle, we have a disk, and yes, it is the correct answer. Okay, try some of these on your own. I find them challenging at first, but it'll give you, you'll really gain some confidence in picturing things 3-dimensionally.